value when using a randomization test?
Yes, so this is something that it's done in statistics. We simulate the experiment. And we're going to try, there is an example here. I was just trying to see, to make that applet work. So we'll see in a moment. Now, I'll read this one. It's a study of 576 cities around the world. And they say that it appeared that the mean cost of a loaf of bread was slightly higher than the mean cost of a bottle of water. Given the variation among the prices, could that difference be due just to chance? To examine that further, we took 1,000 random samples of 100 cities and computed the difference between the mean price of a loaf of bread and a bottle of water. The histogram shows the mean differences. So they created the mean differences, and they just created the histogram. Okay. Now, if there is no real difference between the mean prices for a loaf of bread and a bottle of water, where would you expect the center of the histogram to be? If there is no difference, no real difference, it should be at 0, because we're looking at differences. So the mean prices, right? Where would they expect the center of the histogram to be? At 0. And not around the difference. Not around the difference. Would expect the histogram to be centered around 0, which would indicate that the mean prices were equal. And one would expect the histogram to be centered around 0, which would indicate that the mean prices, the median prices. Of course, we're not talking about the median prices. We're talking about mean prices here. In the mean prices. So there again, they're trying to catch us between the median and the mean. So we're talking about center around 0, which would indicate that the mean prices were equal. Not median. Okay. So this one, this is an example that we looked at before. Suppose an experiment was done to gather data on the number of unpopped kernels of microwave popcorn. Half of the subjects took home a bag of popcorn, put it in the freezer overnight, and popped it the next day. The other half did not, and they put it on the counter, and they popped it next day. True or false? So the set of hypotheses shown below represents whether the freezer method left fewer. So mu1 freezer, fewer unpopped, less than. Mu freezer, less than mu counter if you move that to the other side. So this is true. So this or this are the same, as we discussed several times. Now, let's read this problem. So we have 4, 5, and 6 to finish. So we have the data. We're going to open the StatCrunch in a minute. But let's identify the explanatory variable in this study and what is the response variable. So let's read it. Anyone would like to help with this one?
I'll read it.
Thank you. It's the same problem we looked at before with carpet and no carpet.
Researchers wanted to determine if carpeted rooms contain more bacteria than uncarpeted rooms. To determine the amount of bacteria in a room, researchers pumped the air from the room over a petri dish.
Yeah, it's a petri dish, yes. To check the bacteria.
Okay. Of 1 cubic foot per minute for 8 carpeted rooms and 8 uncarpeted rooms. Colonies of bacteria were allowed to form on the 16 petri dishes. The results are presented in the accompanying table.
Good. So we looked at the results over there here, but what is the explanatory variable in the study? And what is the response? So we have carpeted and not carpeted. And the response, bacteria or no bacteria, or the quantity of bacteria, right? So the explanatory variable, are they carpeted or not carpeted? That's the explanation for the bacteria. What the response, as they said here, cubic feet of bacteria. Bacteria per cubic foot. Good. So now let's think about the null and the alternative. They wanted to determine if carpeted rooms have more, the keyword is more, bacteria than uncarpeted rooms. In words, explain what the null hypothesis would be for the study and the alternative. Anyone else I haven't heard from, please? What do you think? It's okay if you're wrong.
Wouldn't the null hypothesis be that there's no difference, and then the alternative would be that there's greater or more?
Yes, exactly. So the null hypothesis, there is no difference. So we cannot look at the first one, so we have to look at the last three. As there is no difference, there is no difference in the bacteria count. But now we have to be careful because the alternative, according to the claim, is that carpeted rooms have more bacteria. The alternative hypothesis is that carpeted rooms have a higher bacteria count. Carpeted rooms have a lower. No. Is a difference in bacteria count, so is that there is a difference. So correct. Very good. Well done. Okay, so mu1 minus mu2, they have to be equal. In this case, if they are equal, the difference is 0. If that is 0, this must be 0 for sure. And as you said, greater than. In other words, mu1 is greater than mu2. It's a similar way of writing the hypothesis. What would be an appropriate test statistic? On what? On the difference of the means, on the sum of the means, of the overall mean, or the product? We never talked about sum, overall mean, or product. There is no such thing. So we are, as we see here in the null and the alternative, we're talking about the difference. That's the test. The test is on the difference of the means. Okay, so that was exactly what I was doing before we started today. I was playing with this applet. So let's give it a shot. I didn't get the chance to make it work. So let's see, maybe together we can. So I'm going to click on Open a StatCrunch. And it's asking us to go to, once it opens the data set, to the applets, and to resampling. And we have to choose from here what we're doing. We're doing a resampling, a randomization test for two means. Then we select column 1. We select column 2. It's asking us to use and enter a fixed seed. So I don't know if I can take this aside so we can. I hope it didn't disappear on me. No, it didn't. Okay, so use the randomization test for two means. We did. Applet in StatCrunch, yes. To build a null model to generate 1,000 repetitions of this study to obtain a p-value and then interpret the p-value. So we want to generate 1,000. So obtain the 1,000 sample by using the seed value 12361. 12361. Okay. Identify the steps. Applets resampling. Okay. Under sample 1, select the data containing carpeted. Sample 2, uncarpeted. using seed, select use. I don't understand why they're asking us to enter the same. I understand. They are telling us to enter 1, 2, 3, 6, 1. Okay. So then I will enter fixed seed as 1, 2, 3, 6, 1. Okay. And title. It doesn't tell me where to put the 1,000. I can't see where to put the 1,000. They want us to 1,000 simple random samples. And then click compute. In the resulting, okay, I'm assuming that it pops up with 1,000 already. Okay, 1,000 times. Okay, so I was just looking to see where is the p-value. So in the resulting pop-up, press the 1,000 times button. Type whole numbers. Okay. You in the result, press the 1,000 times button. Okay, I did. And press OK times button. It just asks me to press it several times and to tell them, okay, I pressed it once, twice, 3 times. Okay, I selected 3 times. Okay, now what? So I don't understand what they want us to do next. Type whole numbers. It's not clear to me how this applet works to determine the p-value. Proportion, reset, okay. I don't see where the p-value is. I have no 1 time, 5 times, 1,000 times, reset, analyze, analyze. Okay, what's... Oh, I know what that means, but what is the info? That's exactly what I was doing before we started playing with this applet. So I don't understand what it's asking right now at this point. In the resulting pop-up, press the 1,000 times button. Okay. So what type whole numbers? I'm not sure what it wants. Yes, that's what we did. Identify the options that need to be selected in the pop-up window to generate the required samples using the given seed value. Be sure to type whole numbers. I'm just going to click OK, and maybe it will give us what they correct answer. Ah, okay. So I thought, okay, so just keep in mind they want you to put 1. Okay, and now the p-value, but where is the p-value? Where is the p-value? Count, proportion. I have no idea where the p-value is. So this was a one-tailed test. I can find the p-value. 1.4125 count. This is not a percentage. Proportion or above. So I guess proportions of or above 0.181. I'm just going to put that 0.181. Yeah, I know what the proportion for the p-value is. I don't see what else can be the p-value. I will further investigate. Of course, you're not going to have to do any of this, but I would like you to know what it is for this. I know I'm going over, so I still have for Monday 4, 5, and 6, or 5 and 6. The graph is clear. The graph is definitely clear, but I'm not sure what needs to be done to determine the p-value from their simulation. But just remember that all they want in here is just for you to put once. Don't click on the button more than once. It makes no sense. But anyway, thank you for your patience. So just remember, this is problem 4 on the last homework. I just wanted to quickly look at, yeah, they may ask the same thing on the other problems. Yeah. Okay, so you don't have to do the last 3 problems from this last assignment till I figure out